Okay, so our goal by the end of this video is to be able to determine areas within any normal distribution. So for that, we're going to need to work with what's called the standard normal table. So let's first review again what we mean by a normal distribution. So we define the standard normal distribution as the normal distribution where it has a mean of mu, standard deviation of sigma, and that when it's standardized, using this value for the z-score, then the mean is going to be 0 and the standard deviation will always be 1. So recall from the previous section, the z-score is also known as a standardized value. And it's basically a measure of how far that value is from the mean value in that distribution. So let's go through some practice problems, because again, that's always the best way to make sense of this stuff. So what we're typically going to use is a table called a normal standard table or standard normal table. In our textbook that I use for this course, it's it's table A in the back of the book. And typically in any stats course, you're going to be given some sort of handout or reference sheet where you can look up these values. And it's always good to have it handy when you're working on your problems all throughout this course. So what it does is essentially lists all these numbers. It may look confusing at first, but these values tell you what the area is to the left of the corresponding z-score. So let's first let's go through these couple ones by drawing a curve, and then we'll break it down more thoroughly. But this is what it will typically look like. So we're going to draw a curve that represents what we're looking for, and then we're going to figure out what that area is. So we're trying to find the area to the left of 1.51. This is what that's essentially saying, because z is going to be less than 1.51. So we would draw again. Let's draw a sketch of a bell curve. That didn't work out too nicely. It's a terrible bell curve. I need to work on that. But again, in a bell curve, when it's standardized, the mean is going to be 0. So 1.51 is going to be somewhat to the right, because positive z values are to the right and negatives are to the left. And so we're trying to find the area indicated by here. Roughly speaking, it's not a perfect sketch, obviously. Now, in this case, z is less than 2.71. So we're trying to find the area to the left of 2.71. Again, draw a bell curve. 2.71 is going to be more to the extreme end. Again, we're talking nearly almost 3 standard deviations to the left. So we'll say 2.71. So not drawn perfectly to scale, just to give you a rough idea. So we're trying to find all that area. Okay, so let's first do these two examples. So in your table, on the outer margins, you're going to have the top row, and the left column represents the z value, the digits in your z value. So the left column represents the first 2 digits. So the singles place and then the tenths place. So negative 3.4, negative 3.3, negative 3.2. And the top row is going to represent the 2 digits to the right of the decimal point, or the tenths and hundred spots. So this would correspond to negative 3.400. This would be negative 3.401. This would be negative 3.402, and so forth. Now, these are negative values. So because again, we have negative z values, and we also have positive z values. So these on this second page, still representing z values, but here those z values go from 0 and upwards. So 0, we have 1.0, all the way to 3.4. And again, these are the tenths and hundredth spots. And what the values in the center of the table represent are the areas to the left of the corresponding z value. So for example, if we're going to look for the area to the left of 1.51, we're going to first look for 1.51 in our z table. So we're going to, again, it's going in, increasing order as you go downward. So 1.5, this would be 1.50. This would be 1.51 because you see you have the 1.5 and the 1 in the hundredth spot here. So this is saying that there's an area of 0.9345 to the left of 1.51, 0.9345. So that's what that area is. You can also say 93.45% of the total area. Now, we're looking for the area to the left of 2.71. Again, since it's further to the right than 1.51, the area is going to be larger. So we look for 2.7 first in this column. And then we go till this, to match it in this column, 2.7. And we're talking about this value here, because that's a 2.71. And this is saying that 0.9966 of the total area is to the left, or 99.66% of the total area is to the left of 2.71. Because remember, the total area has added up to 1 in a density curve. Now, for C, we have a negative z value. So the concept is the same. We want to find the area to the left or below negative 1.41. But let's remember that negative 1.41 is going to be to the left of the middle, because remember, the mean of a standard normal curve will be 0. So negative 1.41, we could say it's over here. And so we're trying to find this area here. So instead of using this side, we go to the first side that we were at. And we look at negative 1.4. And that would just be this first one because it's negative 1.40. So this is saying that there's 0.0808 area to the left, to the left of 1.4, 0.0808, or you can say about 8.08% of the total area. And now let's step it up. Now let's look at the other direction. What if you want to find the area to the right of a value? Because remember, saying z is greater than 1.61. So 1.61 again is a positive value. But we want to find the area to the right because we're saying greater. Now, this table tells you the area to the left. So we want to find the area to the left of 1.61. We would go, on the positive side to 1.6, and 1.61 would be over here. But it's not going to be 0.9463 because that's the area to the left. That's this blank area here. But since the total area has added up to 1, you just subtract 0.9463. Let me erase this so it's a little more clear. 0.9463. If you just subtract that from 1, then that's going to give you what that area is. So we do 1 minus 0.9463. And that area would then be about 0.0537. And there's more than one way to do this. That's just one of the methods. So likewise, you can apply this same technique for negative z values. So we want to find the area that's to the right of negative 0.71. Remember, it's negative, so we're going to have, maybe somewhere over here. And you want to find this area. So we go again, we look at negative 0.71. So go to the original side. So negative 0.71. Remember, this 0.2329 tells you the area to the left of 0.71. So since it's the area to the left, to find the area to the right, you just do 1 minus 0.2389. And then that will give you the area to the right. So 1 minus 0.2389, get approximately 0.7611. Now, another way to do these ones is if you are picking up on this pretty quickly. Since this is a symmetric curve, the area to the left of negative 0.71 is the same as the area to the right of negative 0.71. So let me just draw like another sketch right here. Let's say if I want to find, the area to the left of 0.71, that would be the same as this. Because again, it's symmetrical. So I could actually just go straight to my table and go to the 0.71. And you see I get the 0.7611. So either way is fine. It doesn't matter how you want to solve these problems. Just make sure you understand what you're doing. All right, now let's look at cases where you have to find it between two z values. So we want to find the area between negative 0.58 and 1.79. So not my best one, but let's say this is the center 0. So negative 0.58, let's just say it's something over here. And 1.79, like that. Okay, so we want to find the area between two z values. Again, I'm just going to show you one of the ways. There's more than one way, which I do whatever way makes the best sense and is easiest for you. One way you can go about it is to find the area to the left of 1.79, because that's going to give you everything, all to here. I'll give you everything, from here to here. And then from that, subtract the area to the left of negative 0.58. So take the bigger area, you could say, and from it subtract the small area. And I like to say like this. This is one way this is not technically like a formal notation. I'll say take the z of 1.79 and from it subtract the z of negative 0.58. So the area to the left of 1.79, we go look at our table. Let's see what we get, 1.79. I'm gonna go for pretty much all to the right. 1.79. So we get 0.9633. We get 0.9633. And then subtract the area to the left of negative 0.58. So we look at the area to the left of negative 0.58. So negative 0.5. Oh, wait, here, that's going to be 0.281 minus 0.281. And we would get 0.9633 minus 0.6823. All right, let's look at another case of that. Let's look at the area between 0.79 and 2.81. So we draw a normal curve to get a basic idea of what we're looking at. 0.79 to the right of the mean, And 2.81, very far to the right of the main. Probably can't even see like the area there. And again, we can take the area to the left of 2.81, which is all the way to that. And from it, subtract the area to the left of 0.79. So again, I like to call this, take the z of 2.81, the area to the left of 2.81, and from it, subtract z of 0.79, or the area to the left of 0.79. And so let's go to our table again. So 2.81, that is 0.9975. And then the area to the left of 0.79, 0.79, 0.7852. Let's see what we get. 0.9975 minus 0.7852. Yeah, 0.2123. Now, when you're first going through these, make sure that you're thinking as you're solving these, meaning that make sure your answers make sense. That's why it's a good idea to draw a picture. So like, when you have this, that the area is going to be, somewhat small. It's not going to be like above 50% or 40%. Whereas, in this case, it's going to be above 50%. This case, again, it's going to be less than 50%, but, somewhere in the middle. So make sense of it. That's why it's always good to draw a picture. Next, we're just going to look at what we do in the cases when we're given the percent and then have to find the z-score. So let's say we want to figure out the z-value given at the 30th percentile. So let's first again draw a sketch of what we're looking at. And with our mean is in this center, or z-score of 0. And remember, the 30th percentile is essentially the value where there's an area of 0.3 to the right. So this area, or sorry, 0.3 to the left. So this area, we 0.3. So we want to figure out, what is the z-value? The z-value equals what? So for that, you're just working backwards. So instead of going from the z-value to the area, you go from the area to the z-value. So since the z-value is going to be to the left of 0, we know our z-value is going to be negative. So let's turn to our negative side. And these values are going in increasing order. So we go until we can find the value closest to 0.3. So again, they're increasing. And okay, now over here, we're getting close to 0.3. So we have 0.3085, 0.305, 0.31, 0.3015. So it's gonna be somewhere between here and here. Now, it won't actually be necessary to be exact. Your teacher won't mark you down if you don't have the exact value of 0.3 in your table, which is because it's not gonna be your fault. But just pick the one that's closest. So 0.3015 is actually closer to 0.3 than 0.2981. So we look at the z-value that matches this, and that's going to be a z-value of negative 0.52. So then we can write that this z-value would be negative 0.52. That's essentially what we're looking for. So likewise, if we're looking at the 60th percentile, I don't know what's going on with my normal curve. We're looking at the z-value where there's an area of 0.6 to the left. So that's our mean in the middle. 0.6, we know it's more than 50%. So something like this. the shaded area has to be about 0.6, roughly speaking. So we know our z-value is going to be positive since it's to the right of the mean. So again, we look at our normal table. We look for the value in the middle that's closest to 0.6. So we're going up. And here we have 0.5987 and 0.6026. So the one that's closest to 0.6 is the 0.5987. And so the z-value that goes to that is 0.25. And so we could say it's going to be, and we can do approximately. It's not as exactly, but z is 0.25. Now, if the question is worded differently, don't let that throw you off. It's essentially the same thing. If it says 35% observations are greater than z, so we look at our middle or mean right here, saying that, the area is 0.35 here. 35% of the values are greater than z, but then that means that the area to the left is going to be 0.65 because 0.65 plus 0.35 was 1. So you're just looking for the z-value that has an area of 0.65 to the left. So again, we know our z-value is going to be positive since it's to the right of 0. So we go to our table, look for the area that's closest to 0.65. Looks like it's going to be over here. And the closest one will be this one, the 0.6517. And that would match up with the 0.39. 0.39. So you can say our z-value is approximately 0.39.